Hi everyone, here we are, second to last lesson in geometry honors for some of you. I'm so excited. Today we're gonna do lengths of chords, secants, and tangents. I know this is the moment you've been waiting for, folks, and here it is. Okay, so we have first up chords. All right, now this is kind of fun. Two chords that intersect in the circle, okay, you can use the following rule. Part times its other part of the chord is equal to, on a separate chord, its two parts multiplied together. Super easy, probably means nothing to you unless we look at an example. So let's look at number 2, okay? It's a little bit more stimulating than number 1. Okay, so you stick on one chord. Oh, helps if I have the pen. So you stick on one chord. I still don't have the pen, people. Bear with me. Okay, so here we go. We're going to stick on one chord, and we're going to multiply the two parts together. So there's an x and a 4, so that's going to be 4x. Now we're going to go to the other chord, and we're going to multiply those two parts together. So 8 times 5, or in other words, that's going to be 40. So 4x equals 40, or part times part equals part times part. Super fun. Let's try some more spicy examples. Whoa, look at all those X's and these down here. Let's look at this first one. I'm jumping around on a couple of these examples because you can always use my note sheet with them completely filled in. I'm going to try the harder algebra examples for you. All right, so let's stick on one chord. So we have 9 times 8. Now, on the other chord, it's 6x times 12x. Oh, folks, look at that algebra. 6 times 12 is 72, and x times x is x squared. Uh-oh. How many answers should we get for x? 2, folks, because it's x squared. Okay, so now I'm going to divide both sides. Equals 1. Oh, shoot. Internet issues. And then I'm going to take the square root of both sides. Now remember, there's got to be 2 answers. So when you take the square root, it's plus or minus 1. But that's kind of naughty because we're talking about the length of a side or a segment. So we're going to reject the negative and keep the positive. So your x is 1. Oh, wait, they want us to find WS, people. WS is 1 times 6, so 6. Oh, I'm frozen. 6 is your answer. Okay, let's go to the back because I now see where it says solve for x. We're going to do some factoring. I love a good factoring problem, folks. And there's nothing better than factoring while I'm having my coffee. Well, I'm going to take the 2 parts. So let's start with the x and the x plus 2 and multiply them together. And then it's x minus 2 as a group times x plus 5. Those are 2 binomials multiplied together, so I better do some fun multiplication there. I can do it. X times x is x squared plus 2x. Double distribute this guy. X squared plus 5x minus 2x minus 10. Oh, there's x squared on both sides. Boom, it's gone. 2x equals 3x minus 10. Move that x to the other side. Negative x is negative 10, or x is 10. Now that problem didn't involve any factoring, but I did have to multiply some binomials together. Let's try one that's got some factoring. Okay, so we have x plus 5 equals 6 times 4. X squared plus 5x equals 24. And most of the time when people see these problems, they leave them blank because they don't know how to factor from 9th grade. But we know, folks, we're moving on to Algebra 2 next year, and you better know how to factor. Those teachers will be cranky with you. X squared plus 5x minus 24 equals 0. I need to, but sum to 5 in the middle. So if I go x plus 8 and x minus 3 as my two factors, 8 times negative 3 is negative 24, and 8 take away 3 is 5. I set each of those factors equal to 0. X is a positive 8 in this case. Oh, just kidding, negative 8, because it was x plus 8. 3. No, I don't want the negative. I keep the positive. So x equals 3 is my answer. That was fun. Okay, chords multiply their parts together and their products are equal. Let's move on to some secants. Woo! Secants are segments that come from an external point and go through the actual circle in two places. So here I have this external. Okay, so this whole thing is the secant. The external is the part that comes from the outside and goes right to the circumference. So this piece is the external. So if you stick on one secant and you take the whole entire secant and multiply its external part by it, it would equal the secant on the other side times its external also. Okay, let's look at some examples here. So I would technically take this whole secant. Now, and times it by its external part. So 4 times x plus 4 is going to equal this whole secant, which is 16, times its external part, which is 6. So 6 times 16. 4x plus 16 equals 96. 4x equals 80. X is 20. On the next one, though, I got a lot of stuff going on. I got to figure out the whole secant on the outside. Well, part of it's x minus 8, and then the other piece is 4. So really, that's x minus 4 for its secant. On this side, I have x minus 3, or x minus 5, sorry, and a 3. So that's really x minus 2 for its whole secant. So if I take the external and then the 3 times the x minus 2. 4x minus 16 equals 3x minus 6, or x equals, if I add 16 over there, I'm going to get 10. Now they want us to find from n to L. So 10 minus 8 is 2, and 2 and 4 give me 6 for that piece. That was super easy, folks. That was just our secant. Oh, I was frozen. And I'm still frozen. No, I'm not frozen. Okay. Our next and last rule for the day is secant tangent rule. Okay, secant tangent rule says the tangent squared, this guy's our tangent. So if you take the tangent and square secant times its external part. Okay, this is different than the last one because this is a tangent and a secant, and the last one was two secants together. Okay, let's do it. We can do it, folks. We've got this guy here. We've got our tangent. So I'm going to take the 6 and square it. It equals the external, which is 5, which is x plus 5. Okay, so I have 36 equals 5x plus 25. Or I have 11 equals 5x, or x is like 2.2, I think, if you divide it out. That was kind of boring. Let's try this one. Okay, so now we have x squared, tangent squared. This whole guy is 12 and its external is 8. Just kidding, bad teacher. That's the internal, please. We want the 4, right? Okay, so we want to times it by 4. So now I have x squared equals 48. Uh-oh, take the square root. There's got to be 2. 48 down because that's an ugly radical. It's really 16 times 3. So this is 4 radical 3. Am I going to keep the negative? No. So it's 4 radical 3 for my answer because I would reject the negative length on there. What do we got down here? Holy cow, folks. Look at this thing. Save the best one for last. I put it there. Okay, so I've got some of you animals who are not as good at algebra would think that's really x squared plus 9. That's wrong, folks. That means there's an x plus 3 times another x plus 3. There's 2 of those quantities. And since you're geniuses, you know that's x squared plus 6x plus 9 when you double distribute. Some of you should be able to do that in your head by now. On the other side, I'm going to take the x minus 3 and times here, which is really x plus 13. Why is that not writing? Let's try it over here. X plus 13. Okay, so now I'm going to multiply that out. I got x squared plus 13x minus 3x minus 39. X squared x. Turns into plus 10x minus 39. It's our lucky day because these x squares are going to cancel. So I'm going to move this 6x to the 10x. So now I have 9 equals 4x minus 39. I'm going to move that 39 to the other side, or x is 16. I want you to find from n to m. So 16 plus 3, 19 for my answer. That was fun. And that concludes your second to last lesson, folks. I can't wait. We only have one more lesson left to learn for our geometry career, and it'll be equations of a circle. Next week, if I can ever close this down, is gonna ever close? You never know. Bye, guys.